From now, I'd like to start my oral presentation. My name is Jee Young Kim from Department of Food and Nutrition in Kosin University. Today, I'd like to talk about the research of the solvent extraction of silver using diethyl-acetamide-substituted p-t-octylcalix in nitrate media. In the beginning, I'd like to briefly introduce about background of my research work. Solvent extraction utilizes the inherent difference in the solubility of a target chemical in aqueous and organic phases and is based on chemical transportation at the liquid-liquid interface. So, in the solvent extraction system, properties related to interfacial active spaces directly reflect on the interfacial tension, which plays a key role since the transport of metals occurs through the liquid interface. Therefore, it is meaningful to investigate the behavior of the interfacial tension in solvent extraction system. So, how can we investigate interfacial tension? The droplet method is a standard method for measurement of interfacial tension due to its convenience and simplicity of handling. In this slide, I'd like to introduce about precious metals. Precious metals, including silver and gold and 6 platinum group metals, possesses specific properties and have been applied extensively in many industrial spheres. Precious metals and their compounds have been widely used as electronic devices, chemical catalysis, and jewelry, as so on. However, never-ending demand of precious metals in industrial technologies and other spheres has prompted extensive researches into new methods for the recovery of precious metals from spent materials or low-grade ores. As known well, the separation and purification of these metals usually are of difficulty owing to their similar structures and chemical behaviors. Thus, it is urgent to develop efficient approaches for the recovery and separation of precious metals. Moreover, preparation of special and useful extractants for the separation of precious metals. So from now, I'd like to briefly examine about calix arene as a solvent extraction reagent in our research work. Calix arenes are a class of cyclooligomers with defined upper and lower limbs. In more detail, in the case of p-t-octylcalix arene, as shown in this figure, a functional group of upper limb is fixed as p-t-octyl and lower limb can be changed by various types of functional groups. Generally, calix arenes are well known as very attractive and interesting host compound. Then calix arene have a high metal discriminating ability. Thus, calix arene derivatives are used as extractants for precious metals. Especially silver has been investigated more frequently than the other metals. From now, I'd like to talk about solvent extraction. Solvent extraction, also called liquid-liquid extraction, is one of major separating operation technology in hydrometallurgical processes. Processes for the separation and purification of precious metals. Solvent extraction processes is a potential alternative refining technology as is on ion exchange processes. In general, solvent extraction processes utilize the inherent difference in the solubility of target chemical in aqueous and organic phases. And then one of the most important factors in metal extraction is the selectivity of the extractant towards certain target metal ions. In the experimental section, we designed calix for arene derivatives as solvent extraction reagent by changing functional groups of lower limb. We synthesized di-ethylacetamide-substituted p-t-octylcalix for arene as p-t-octylcalix leaves high electron density of carbonyl oxygen atom due to high polarity of amide group. So next is in the experimental method of our research work. First of all, silver extraction rate was investigated by the batch-wise method as following this method. Experimental condition was like this. Both phases were mixed and shaken at 303 Kelvin for eukaryote times. After phase separation, silver concentration was measured by ICP-AES. The amount of the extracted silver ion was calculated by this equation. And then, in the research work, conducted measurement of interfacial tension by drop volume method as following this. From such experiment, we studied the interfacial activity of EATOC. Experimental condition was like this. From now, I'd like to examine about the obtained results. In the beginning, we investigated that the amounts of silver extracted depending on extraction times using di-ethylacetamide-substituted p-t-octylcalix as EATOC in nitrate media. As shown in this figure, extraction equilibrium reached approximately 90% within 20 hours. Then extraction rate of silver with EATOC in 1.0 mole nitric acid is slightly faster than in 0.1 mole nitric acid. Secondly, we conducted interfacial tension study. As follow in this figure, as the EATOC concentration in nitrate media increased, the interfacial tension gradually decreased. Then, the interfacial tension of EATOC in solution in 0.1 molar nitric acid is slightly higher than that in 1.0 molar nitric acid. It means that the extractant on contact with the latter is easily observed to the interfacial compared to the former. Namely, the extraction rate of silver in 1.0 molar nitric acid is slightly faster than in 0.1 molar nitric acid. Next, we examined the slope analysis to determine the extraction equilibrium constants. Firstly, in left figure, the distribution ratio dependent on the concentration of EATOC shows a straight line with a slope of 1.0, indicating that the carbonyl oxygen atom of EATOC are coordinated to silver ion to form a one-to-one stoichiometric compounds complex each other. And in the middle figure, the distribution ratio of silver ion depending on nitrate concentration shows a slight straight line with a slope of 0.91. 0.91, which suggests one-to-one stoichiometry as well as the nitrate as counteranion being included in extraction processes of silver ion. Finally, in the right figure, the slope of the straight line is about 0.18. which indicates that a proton is not engaged in extraction processes. After that, in the extraction process of silver ion use EATOC, the NMR spectra were run before and after loading silver ion to elucidate the interfacial interaction between them from proton NMR chemical shift. The As shown in this figure, so the double peak assigned two aromatic protons of calix arene was shifted to the lower field 6.75 to 6.91 ppm after silver loading. So carbonyl oxygen atoms, the donor in EATOC, are coordinated to silver ion by occupying its coordination spheres. After forward extraction, we also investigated that the efficiency of silver ion by backward extraction with various stripping agents. In this table, silver loaded in the organic basis by EATOC was de-extracted with various stripping agents, and its recovery efficiency is summarized in this table. The most significant results were achieved by over 70% in both 0.1 molar and 1.0 molar thiourea aqueous solution. Finally, these are the conclusions in this my research work. Diethylamide derivative of calix arene was used to extracted silver ion from nitrate solution, which was well extracted in its wide concentration range, and the extraction rate was not fast, but which seems to be attributably to the law of absorption properties on the interface of EATOC. Third, the stoichiometry of silver ion and EATOC produce a one-to-one complex. Finally, as a backward extraction, thiourea was the most effective agent for backward extraction. Thank you very much for my kindly attention in this my presentation.